Welcome back, everyone. We're diving into something pretty cool today.
Yeah, definitely cool. And complicated.
Oh, absolutely. We're talking data consistency at mind-boggling scale. Think Meta, Facebook, Instagram, that kind of scale.
Exactly. The kind of scale where a single hiccup can have a domino effect.
And you wanted to know how they keep everything running smoothly, even across different continents.
Right. It's a delicate balance between speed and resilience.
Absolutely. To really get into this, we're digging into Meta's research on FlexiRaft. It's actually a modified version of something called the Raft algorithm.
Which, luckily for us, has its own paper. In search of an understandable consensus algorithm. It's like the instruction manual for Raft.
Perfect. So
Yeah.
we're learning the rules of the game before seeing how Meta changed them.
Exactly. Think of it this way. Meta's data centers are spread out across the globe, right? Each one has a ton of MySQL servers storing just mountains of data. We're talking petabytes here.
Wow. Okay, so before FlexiRaft, they used what's called semi-synchronous replication.
Right. You've got a primary server that's basically keeping a log of every change to the data,
Like a super detailed diary.
pretty much. And you've got local servers making backup copies.
So they've got a safety net right there.
But, coordinating across different regions, especially at Meta's scale, that wasn't exactly a walk in the park.
Yeah, I bet. And what happens if that primary server goes down?
Well, before FlexRaft, they had to manually choose a new one.
Oh, wow. That sounds slow.
Very slow, especially at Meta scale. That's where
Mhm.
RAS comes in. They needed something automatic, something more robust.
Something to keep the data in sync without all the manual work.
Right. Interestingly, they went with Raft over MySQL's own group replication, which is based on another algorithm called Paxos.
I've heard of Paxos. Why choose Raft?
Two main reasons.
Yeah.
Simplicity, for one. Raft's designed to be understandable.
Always a plus when you're dealing with something this complex.
Exactly. The second reason is that Raft uses this persistent log.
That super detailed diary we were talking about?
Yep. It's an unchangeable record of every decision made about the data. It helps with tracking and recovery.
Okay, starting to see why understandability was important. But even with Raft, I'm guessing Meta still faced some challenges.
Oh, definitely. Raft, in its original form, had a couple of issues. For starters, the server in charge, sends updates directly to all the other servers.
Okay, imagine all that data flying across continents.
Exactly. The network traffic would be insane. And then there's the issue of latency. Before any data can be considered safe, a majority of servers in all the regions have to agree.
So they had this back and forth across the globe just to make sure everything's synced up.
And as you can imagine, that takes time. It's like trying to have a meeting with people in different time zones. Things slow down.
So they had to choose fast updates with potential risks or slow but steady consistency. Tough spot.
A classic dilemma. And that, my friend, is where FlexiRaft comes in.
Finally, the moment we've been waiting for. So FlexiRaft, this modified raft, what's the secret sauce?
It all boils down to this brilliant concept called flexible quorums.
Okay, I'm intrigued. Flexible quorums, huh? What are those all about?
In a nutshell, it gives engineers the power to choose how much consistency do they need, how
Yeah.
much speed. It's like a dial they can adjust based on the situation.
So they're not stuck with one-size-fits-all approach anymore.
Exactly. They have options, choices. It's all about trade-offs, speed, consistency, and how resilient they want the system to be across different geographic locations. And FlexiRaft gives them the tools to find that balance.
That's some impressive engineering. All right, let's unpack these flexible quorums. I'm all ears. Okay, so we've got these flexible quorums, and I'm still trying to wrap my head around how they actually work.
Well, there are two main types, static and dynamic.
Mhm.
Static quorums are, well, kind of like they sound.
They stay the same.
Yeah, exactly. You set the rules up front, like, okay, we've got data centers in North America and Europe,
Makes sense.
and you decide, for data to be saved, does it need a majority vote from both regions?
For super strict consistency.
Right. Or is it enough if one region gives the thumbs up?
So even if one entire region goes down, the other can keep things running.
Exactly. That's the trade-off with static quorums. More resilience, but maybe a bit less strict on consistency.
I see. So it's about choosing the right balance for your needs.
And the cool thing is, FlexRaft gives you that choice. The research paper actually has this example where one data center goes completely offline.
Oh, wow.
But because they had a static quorum set up for high availability, the whole system just kept chugging along.
That's amazing. So even with a major failure, they didn't lose any data.
Exactly. Now, dynamic quorums are a bit different. They're more, well,
That's good to say dynamic.
yeah. So instead of having fixed rules, the quorum needed to commit data, It changes
It changes based on what?
based on where the leader is. So if the leader and most of the servers are all in one region, say North America,
Okay.
then the quorum only needs to be met within North America. Less back and forth across the ocean, faster updates.
So it's all about keeping things local and speedy when possible.
Exactly. But here's the catch. Dynamic quorums are a bit more vulnerable to, let's say, coordinated failures. Imagine the leader's region goes offline.
Oh.
Yeah. If a majority of the servers in another region also go down at the same time, the system's kind of stuck.
Can't elect a new leader, can't save new data.
Exactly. The paper has this really cool diagram that illustrates this potential vulnerability.
Yeah.
It shows how if specific servers fail in just the wrong way, it can cause a major disruption.
So it's a trade-off again, speed versus resilience. Dynamic quorums are faster, but a bit riskier.
You got it. And that's the beauty of FlexiRaft. It gives you the tools to choose your own adventure. Static or dynamic, stricter consistency or faster updates. It's up to the engineers to decide what works best for their specific needs.
It's like they have this whole toolbox to work with now.
Exactly. But, actually implementing FlexiRaft in the real world, it's not just about these core concepts.
Right. Real-world systems, there's always a catch.
Always. Meta's engineers, they had to come up with a bunch of clever optimizations to make it all work smoothly. Like, think about vote counting.
Okay, how do they make sure they're counting the votes efficiently?
Well, they made it asynchronous within each data center. So a write operation, it doesn't have to wait for every single server to vote.
So it keeps things moving even if one server is lagging behind.
Right. And then there's this thing called quorum awareness.
Quorum awareness. Sounds interesting.
It basically lets the system skip unnecessary steps if votes are coming from servers that aren't actually part of the required quorum.
So it's like, hey, thanks for your input, but we don't actually need your vote right now.
Exactly. It's all about streamlining the process and making it as efficient as possible.
Clever. Okay, so all these optimizations, did they actually make a difference? Was FlexiRaft actually faster than Meta's old system?
That's the million-dollar question, right?
Mm-hmm.
And that's what we'll look at next.
All right, let's get to those performance results. I'm dying to know if it lived up to the hype. So the big question after all that work, did FlexiRaft actually deliver? Was it faster? More resilient?
It really did. They tested it on real hardware, millions of transactions, the whole 9 yards.
Yeah, they really put it through its paces.
Oh, yeah. And the results, especially with dynamic quorums, FlexiRaft was right up there with their old system in terms of throughput and latency.
So they basically got all the benefits of FlexiRaft, the flexibility, the resilience, without sacrificing performance.
Exactly. But here's the kicker. Unlike traditional Raft, with FlexiRaft, performance doesn't get worse as you add more servers.
Wait, really? I always thought more servers, more complexity, more things to slow you down.
You'd think so, right? But with those dynamic quorums, the number of servers actually needed to make decisions, it stays pretty small.
Even as the whole system grows.
Exactly. It's like having these small, agile teams within a massive organization.
Okay, that makes sense. So even as Meta grows, FlexiRaft can keep up.
That's the idea. You mentioned earlier about some non-mandatory Raft features that turned out to be pretty important.
Oh, right. What were those again?
Pre-voting and joint consensus.
Hmm.
Pre-voting is like a safety check before a server tries to become the leader.
Like a little campaign before the election?
Yeah. It checks with other servers, sees if it has enough support, helps avoid disruptions.
Especially with dynamic quorums, where those coordinated failures can be a problem.
Exactly. It keeps things stable, prevents unnecessary leadership battles.
Okay, that makes sense. And what about joint consensus?
That's all about changing the cluster membership, like adding or removing servers.
So like if they need to take a server offline for maintenance?
Exactly. Joint consensus ensures that the transition happens smoothly, no downtime, no hiccups. It's like orchestrating a shift change without stopping the workflow.
So no sudden system jolts, just seamless handovers. Very cool. So it seems like FlexiRaft really shows how you can adapt and fine-tune even well-established algorithms.
Absolutely. There's no one-size-fits-all solution, especially at meta scale. It's all about finding the right balance, the right trade-offs between speed, consistency, and resilience.
Well, I'd say this deep dive has definitely given us a lot to think about. From the basics of Raft to how Meta created FlexiRaft to handle their massive data needs.
It's amazing what engineers can come up with when they're faced with these kinds of challenges, isn't it?
Absolutely. And to our listener, we hope you enjoyed this deep dive into the world of FlexiRaft and the whole challenge of data replication at scale.
It's a fascinating field, constantly evolving.
As you continue exploring, here's a thought. What other creative solutions are out there, just waiting to be discovered? What other ways can we push the boundaries of what's possible with data?
Food for thought, for sure. The quest for the perfect balance between flexibility, consistency, and performance, it never really ends.
Thanks for joining us, everyone. Until next time, keep exploring, keep learning, and keep those questions coming.